Okay, so this is a psychrometric chart, and this is an alternative way to do problems, and we'll do some examples on this. So don't be worried about this. And then tomorrow we're going to do examples, and I'm going to show you how the tables and using the psychrometric chart can help you. This psychrometric chart saves a lot of time. In fact, ASHRAE, the American Society of Heating and Refrigeration Engineers, has a standard chart, and they have them for different altitudes that you can use. And so what I'm going to say, this is the chart that's in the back of your book. This is the SI chart. It's the same as the English chart. It's the same there. I have taken those and I have put them on Canvas for you to download and print out and to use on your homework if you'd like to. It looks like a very complicated chart, and I understand that. But if we can understand how to use it, it can really simplify things. It can really simplify things. And hey, sorry about that. So we need to understand how to use it. So here's what we're going to do. This is constructed at 1 atmosphere. 1 atmosphere. Okay, and the abscissa, or the x-axis, is the dry bulb temperature. So that's very easy here. This is the dry bulb temperature given to you from -10 degrees all the way up to 50 degrees Celsius. Okay, that's the abscissa. The ordinate, or the y-axis, is going to be the humidity ratio. So this is going to be over here. We'll change the color here. This is going to be the humidity ratio. So you can see this humidity ratio is a very small number. 0.0004 down here at the very bottom. So humidity ratio, kilograms of water per kilogram of dry air, okay? That is that humidity ratio, omega. This is omega, okay? Now, where do we find this? Omega is equal to 0.622 times the partial pressure of the water vapor over the pressure minus the partial pressure of the water vapor. That's where that's coming from, okay? It's a direct relationship. So vapor pressure could also be chosen on the ordinate if we wanted to, but we're not gonna do that. Now let's look inside of this and let's see what happens. There's these curves of constant relative humidity. So let's change our color here. So we have 10% relative humidity. Whoa, that's really thick. Let's go 20% relative humidity, 30, 40, 50, 60, 70, 80, 90. And what's this last one up here that's not labeled? This is going to be 100, or saturation. So you can see all of those lines of constant relative humidity, RH, are provided. Okay. Now, above this is going to be on the saturated line. That last one we give there, that's saturation. That's going to give you the wet bulb temperature, and it makes sense because wet bulb temperature is saturation temperature. It's where you're completely saturated. The air is completely saturated. That wick around it is completely saturated. We're measuring out what the temperature is. So these measurements here, this 30, 20, 10, they're going to be on lines that are diagonal here. So this is going to be the 10 line, 11, 12, 13, 14. A darker line is 15, 16, 17, 18, 19, 20. They're on a diagonal. It's important that you understand they're on that diagonal. They go down there. They start on that saturation line. They go all the way down. So you can see here 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Okay, all the way up there, and then go down to 0. So all the way along that is our saturation temperature, our wet bulb temperature. Above that, up here, is going to be our specific enthalpy of moist air. Okay, this is our mixture enthalpy. Okay, this is going to be HA plus omega HV. That's what they have done there. They have done that calculation for you. Now, this is another one of those datum issues. Okay, on this figure, HA, enthalpy of the dry air, it has a datum of 0 degrees Celsius, which is the same as the steam tables. Okay, not 0 degrees Kelvin, which is what the ideal gas tables have. What does that mean? Why do they have a datum there? Because they keep the vapor, the datum is also at 0 degrees Celsius. We're using this way so that the 0 degrees Celsius for the vapor is used so that we can go and say if there's liquid water dropping out of it, we can use this table. Oh, I should do this way. This way. Everything's mirrored. We can use this psychrometric chart with the steam tables if we wanted to figure out something about when liquid water is coming out of here. So that's where they do that. They want to be able to use this psychrometric chart in condensation. So that's where they make that datum to be 0 degrees Celsius. What this means, however, is because the datum here is at 0 degrees Celsius and the datum of your air tables is 0 degrees Kelvin or absolute zero, that we can't use any table values except for that of liquid water when we use this chart. I'm going to say that again. We cannot use any table values except that of liquid water when we use this chart. You can't mix and match and say, I'm going to take some things from the table and some things from this psychrometric chart. You can't. You can't. You have to say, I'm going to use a chart exclusively, and I can go get water values from my steam tables. If you try to say, oh, I'm going to find this state from the ideal gas tables and this state from the psychrometric chart, and then I'm going to do something else, you have now a hodgepodge of datums, and you're going to get a bad answer. Okay, so it's very important. Now, it's also important to understand this is how this psychrometric chart works. Another psychrometric chart might have a completely different datum. So if you're using a different psychrometric chart, you have to make sure you use that same psychrometric chart for every data point on in your calculation. Okay, most people use ASHRAE charts. This is an ASHRAE chart. You should be okay. But there are some air conditioning companies that have a slightly different chart that might be something that you have to recognize. Okay, I think I have belabored that point enough. Okay, now, as you might note here, this mixture enthalpy, it has a line. If you look, that line is about the same line as our wet bulb temperatures. Okay, and they're about at the same angle here. Okay. Last thing that we're going to talk about here, there's specific volume lines. Okay, so let's look at the specific volume lines, and then we'll be done. Let me change. Come on now. I'll change my highlighter one more time through this lavender color. This is my specific volume lines. Okay, this is specific volume, meters cubed per kilograms of dry air. Now remember, the meters cubed doesn't matter if it's vapor or if it's air, because the volume is going to be the same. But they're saying specifically, it's per kilogram of dry air we're down here. So that's going to be say per kilogram of dry air that we're doing this. Okay, just like any figure, if we get two things where they intersect, that's the point that we have, and that is where we're going to be able to read all data off of. So let's go here and let's use what I found earlier with my. I'm gonna erase everything here. So make sure you have everything right now. I'm gonna erase everything here, and then I'm gonna use the values that I just got in my house here. So erase all of this good stuff. Erase. My family's cleaning up. Can you see back behind me? Oh, you can see. It's getting a little cleaner back here. My family decided they wanted to clean this area up after asking them nicely all summer long. They finally said, okay, we'll do it. Now, we still have some issues of the stuff above my head, but you know what? I'll take it. There's a closet back here full of toys that we don't play with anymore, and they're gonna be given away, and I'm overjoyed, just overjoyed. Okay. I told you the wet bulb temperature was 67 degrees Fahrenheit and 83 degrees. I can't use this table to do that, so I can't do that. So let's just convert here quickly. Let's convert 67 degrees Fahrenheit into Celsius. Okay, let me get to I'm going to Google here. I'm going to do this quick and easy. 67 degrees Fahrenheit in Celsius. That's about 19.4, so it's let's go 19.5 degrees Celsius, and then I'm going to do here 83 Okay, and we're going to do it again. 20, this is about 28. Okay, so it's about 19 and a half and 28. Okay, so let's see what we do. 19 and a half, well, here is 19 and here is 20, so 19 and a half would be somewhere right in between there. So I draw a line, and it's good to have a straight edge right down here. That's going to be my one line, 19 and a half. And my dry bulb is going to be 28 degrees. So I go here to 28. I'm going to go reach right up to where it reads. And that's where they intersect. That's my value there. And it says the relative humidity is going to be about between 40 and 50, maybe about 45, 46% relative humidity, which is what I found with my, about what I found with my sling psychrometer. Again, there is going to be some variation here because you know, this is going to have, you're going to have to draw with a straight edge, and you're going to be between two numbers. So using the psychrometric chart is not an exact science, but you have to be within a range of values to get there. But what this also can tell me now is I can go and I can read off, if I go straight over here, I can now find out what my humidity ratio is. My humidity ratio is going to be 0.011. Okay. It's also going to tell me what my relative humidity, what my specific volume is. My specific volume, here's 0.85 and here's 0.90. I am about 0.86, 0.86, probably 9 meters cubed per kilogram of air is going to be what my specific volume is. I can find out what my enthalpy is, my specific enthalpy, if we just go right up here. My specific enthalpy here, so my HA plus omega HV is going to be about, let's see here, what's this going to be? 51, 52, 53, 54, 55, 56 kilojoules per kilogram of air. That's what I'm going to have there. And the last thing that I can read off this is going to be the dew point. Okay, the dew point and is going to be if we were to cool this down at constant pressure without changing the humidity ratio until we reach saturation. If we were going to cool this down without changing the humidity ratio until we reach saturation, boom, going straight over, that's going to be where our dew point is. And I can say the dew point in this house is going to be about 15 and a half degrees Celsius. Okay, so if I had something that was 15 and a half degrees Celsius in this house, I would start noticing that some condensation would occur on that. Okay, that's how you read this chart. We will have plenty of practice reading this chart, example problems coming tomorrow and the rest of the week. Okay, so to end today, well, I want to mention one thing. We'll do some problems here to end today. But there's another chart that I provided to you. It's on Canvas, and it's called the Train Psychrometric chart. And this is through the company Train that makes the air conditioning. And you can see it's a little bit different of a chart, maybe more complex chart. And we don't need to understand this chart. It's for when after we get the basics taken care of, we really understand how to use the simple chart that we have here. We would say, okay, now let's understand exactly how to use this Train chart or another type of chart. But what I provided it with is there is a directions for using the Train Psychrometric chart is on the back, and it's in very small print. But I think it's a really good reference. So I'm going to provide it to you. It tells you about dry bulb temperature and wet bulb temperature. It tells you about humidity ratio and enthalpy. It tells you about specific volume, dew point. It tells you about all of these things. And so I want you, and it gives you some example problems. So I think this is a really good reference to have as a pocket reference. And so I provide that to you for you to download and use at your leisure. Okay. Now, so reference that one. Let's go back to this one. I want to do a couple problems here, example problems, and what we'll do is we will leave this as you're going to print one of these out, and you're going to try it on your own so that you can be ready for the homework, and you can kind of be participatory today. So what we're going to try to find here is we're going to try to find the relative humidity and the humidity ratio and the mixture enthalpy when the dry bulb temperature is equal to 30 degrees. Let me find something here. I want to find the wet bulb temperature, not the relative humidity. And the relative humidity is equal to 60%. Okay, 60%. So, dry bulb, 30. So let's go here, 30. We're going to be somewhere on this line, 30. Okay, and the relative humidity is 60. Somewhere on this curved line, boom, here's where we intersect. That's what we're going to read off. What is our wet bulb temperature? Wet bulb temperature is going to be going up at a diagonal. Okay, wet bulb temperature is going to be 21, 22, 23, 23 and a half. So temperature wet bulb is going to be 23.5. Okay, what is our humidity ratio? Okay, we're going to go over here. Humidity ratio is equal to 0.016. Okay, what is our mixture enthalpy? I'll say that the mixture enthalpy, HA plus omega HV, is equal to 70 kilojoules per kilogram. I should probably put here, this is degrees Celsius, this is kilojoules per kilogram of air per kilogram of air. Easy peasy, easy peasy. Okay, what is the dew point? Well, I just go straight over here to the dew point. The dew point's going to be about 21 degrees Celsius. 21 degrees Celsius. Okay, here's what I want you to find. So this is for our quiz question today. What you're going to do is you're going to say for a temperature dry bulb equal to 30 degrees and a temperature wet bulb is equal to 20 degrees Celsius, what is the dew point? That's going to be your question, and then we will move on. So today we're trying to get how to use these tools. We will use these tools to do calculations starting later on this week, starting tomorrow and the rest of this week, and this will be the last new question that will be provided to you on your exam. So you're going to have isentropic efficiencies, ideal gas mixtures, psychrometric mixtures, and dealing with a psychrometric chart. Those will be your 3 questions. There will be a 4th question, which is going to be something comprehensive from somewhere in the rest of the semester that you are going to have to answer. Okay? That's where we'll be going, and we can end the lecture here, and we'll see you later.